Hello, right, welcome to your first additional video. Everyone else has had loads of videos, but this is the first one for you guys. I know Straddle's been putting some work on for you. The next thing I would have been teaching is integration, which is the opposite of differentiation. So maybe you'd like to start, if you can remember anyway, if you pause the video, differentiating these expressions. Okay, so if you pause it and give it a go, the rule, remember, is you multiply by the old power and drop it by 1. Okay, so multiply by the old power and then drop the power by 1. You do need to be in index form though. Okay, these ones already are. Okay, right, answers. So dy by dx, bring the power down and multiply, so 7 comes down and multiplies, so that would be 56 x to the power of 6 plus 2. It would have been to the power of 1, the 1 comes down, multiplies, disappears, and the minus 23, that just disappears. Okay, so it doesn't have any x's in, it's a constant, it just disappears. So 56 x to the power of 6 plus 2. For the second one, dy by dx, so the original power comes down and multiplies, drop the power by 1, minus 9. And for the third one here, the old power comes down in front and multiplies, so 3 over 2 x. Now then, if you're on 3 over 2, 1.5, and you drop by 1, what are you left with? You're left with just a half. It's like taking away 2 over 2, which is like same as taking away 1. Okay. On the second set, which are similar, so on the first one here, I'll switch to red. The 5 comes down and multiplies, so 35x to the power of 4, because you drop the power, minus 5, the x disappears off there, the minus 2 has gone altogether. Then we've got the minus 6 comes in front and multiplies, down from minus 6 when you drop it is minus 7. And for the third one then, the 3/5 comes down in front and multiplies. Now then, we've got to go down from 3/5 here, we've got to go down by 1. If we're working in fifths, 1 is equal to 5/5. So we've only got 3/5 to start with. If we're taking away 5/5, you're left with minus 2/5. That's quite a tricky one, that one, working in fifths. Okay, so 3/5, take away 5/5, 3 take away 5 is minus 2, so minus 2/5. Okay, on to integration then. So it's the opposite of differentiation, and usually its sort of main application, if you like, is to find the area under a graph. Remember, differentiation is all about the gradient of a graph. So say for instance you had a velocity time graph, sketch one here, look, so this is velocity and time, it went something like that. If you were differentiating, basically you're finding the gradient of a tangent at any one point, which would be the acceleration. If you were integrating, you'd find the area underneath, and that would be the distance travelled, okay, if it was a velocity time graph. So there's some of the applications of integration for you. Okay, get rid of that line, that's a bit weird, just sat there. Okay, so the rule for integration, and an integration symbol, by the way, is like that. Okay, sort of an elongated S. Then you'll have your expression, and then usually you'll be integrating with respect to x. Okay, in other words, x is the variable, the sort of the bit that you do the integration with. If you were doing maybe a mechanics question and it was all about time, where time is the variable, then you'd be integrating with respect to time. Okay, and time is usually t. So, but all it means is that here you might have an expression that's in terms of t, something like that. And here it just means your expression is in terms of x, like that. Okay, just what you're integrating with respect to, what is the variable that you're integrating sort of with. Now, when you differentiate, if I was differentiating x to the power of m, okay, so if that was y, and I'm differentiating, then dy by dx, the rule is the m comes down and multiplies, and you drop the power by 1. So, the opposite of that is to increase, and also let me get rid of that, the integral of x to the power of m, sorry. You would increase the power by 1. It's the complete opposite. You would increase the power by 1 and divide by that new power. Okay, so if you want some really simple examples, if I have to integrate x squared with respect to x, my answer would be increase the power by 1, so it goes up to 3, and then divide by 3. Okay, you could write that as a third times x cubed if you wanted, but it's probably easier just to write it as over 3. Now the other thing you've got to be careful of when you integrate, now let me show you a quick differentiation here. If I was differentiating 4x squared plus 8 dy by dx would be, the 2 comes down and multiplies, it would be 8x, and that 8 would disappear. Okay, so that goes. If I integrate it, so I try to reverse this dx, I would get 8x squared over 2, which is 4x squared, so I get the 4x squared back. But what about the plus 8 on the end? Okay, it was there originally, it disappeared when we differentiated. Well, I'm integrating, so I should be reversing the process, but how can I get the 8 back? How would I know that it's 8 and not anything else? Because it literally could have been anything. But just in case there was a number there, we have to add on what's called a constant of integration. Alright, it's a plus c. Sometimes you get given information to work out what the plus c is. Sometimes you don't. Okay, sometimes it doesn't matter. But you must, when you integrate, include this plus c on the end. And like I say, the reason for that is because when you differentiate, any number just disappears. So when you reverse, you have to take into account any numbers that may have been there, but you don't know what they are. Alright, so that's called a constant of integration. You must remember to include it every time you integrate. If we do another one, look. Let's have 4x cubed plus 3x squared minus 9. Okay, with respect to x, let's have a look. So look at the first term. Raise the power by 1 and divide by the new power. That would be 4x, so the power of 4 over 4. Tidy it up in a second. The next one would go to 3x cubed, raise the power by 1 and divide by the new power. I have to move this over a sec because I'm going to run out of space. The minus 9 will pick up an x, so like x to the power of 1 if you like, over 1, so you don't really need the 1s, in other words, plus c, don't forget your plus c. Tidy that up, that 4 cancels out, x to the power of 4, 3 cancels out, x cubed, don't need the 1s on that one, so just minus 9x plus c. Okay, and like I say, if you were given some extra information, so perhaps they would tell us a value of x and a value of y, we could work out what that c is. Okay, but the general rule for integration, increase the power by 1, divide by that new power, don't forget your plus c. So here's some questions then. Now these are called indefinite integrals. Okay, meaning our answer will be algebra, it won't be a number. There are times, we'll come on to it in a second, there are times when you can actually put values in and get a number for an answer, but these are indefinite integrals. Our answer will just be some algebra. So here we go then. Now first job will be to rewrite this question in index form. Don't want the 1 over. 1 over, remember, is a minus power. So that's x to the power of minus 3. It means 1 over x cubed plus 4. And we're integrating that with respect to x. And all you've got to do then is go one term at a time. So raise the power by 1 and divide. 3x to the power of 5 divided by 5. Raise the power by 1 and divide. Here, raise the power by 1. Well, that just means it picks up an x plus c. And we can do a little bit of tidying up here, actually. The 3/5, not a lot I can do with that. Maybe it'd be a bit neater if I just wrote it out in front, though. That minus, I could leave it as a 2. I think I would prefer, though, for that minus to come up here and make the whole lot minus. And then I just get a normal 2 on the bottom. That's a little bit smarter to have a positive denominator, okay? And just put the minus out in front. Then we've got a 4x, nothing to do there, and then we've got a c. There you go. There's your indefinite integral. For that one anyway. If we move down to another one here, look. Change the colour. Again, it's got to be in index form before we start. So 3x squared. We've got x cubed on the bottom, so that goes to minus cubed, minus 3, plus 8x dx. And then one term at a time, raise the power and divide. That's a nice one because those 3's will cancel out in a minute. Raise the power and divide. It goes to minus 2 over minus 2. This one's at the minute is a power of 1. So it's going to go squared over 2 plus a c. They will cancel. Leaves you with x cubed. That minus, I would bring it up in front. 4 divided by 2 is just 2. So that's the neatest way of writing that second term. 8 divided by 2 there is 4. 4 squared plus c. Okay, that one done. And then if we move down, they're all pretty similar, as you can see. Let's swap to green this time. This one's already in index form, so we can pretty much go straight to our integrating. Raise the power and divide. Power of 5 over 5. Raise the power. At the minute it's a 1. 2 over 2. Raise the power and divide. Well, up from minus 2 is minus 1, and it goes over minus 1 plus c. And tidying that up then, 3/5 x to the power of 5. 6 over 2, well, that's just 3 really, isn't it? So 3x squared. I'll bring the minus up. 8 divided by 1 is just 8. Not really dividing, is it? And that's how you do an indefinite integral. Okay, raise the power by 1, divide by the new power. They can be a little bit tricky with fractional powers, but that's the basic rules. I've only got 15 minutes, so I'll stop this video here and I'll put definite integrals on a brand new video for you. Okay, you can watch both.